Let's talk about 1.4 appetizer questions. We are going to talk about log functions in this section, and let's go over with some review of the log properties together with me. So let's look at those properties. There are about 8 properties, and all of those are fairly easy. And then there are 3 properties that you have to be careful. These are those 1, 2, 3 properties. So let's see if you recall all of those rules for logs. So let's look at this one. If you have a log base a over a to the x, these cancel out each other as an inverse function. So you are going to have x as your answer. Let's look at the example on the right side. If you have a log base 10 over 100, you can write it as log base 10 of 10 to the second power, which you cancel out and it turned out to be 2. Let's continue next question of log 2 over base 16. And log base 2, you can only rewrite as base 2. So it is going to be 2 to the 4th power. That is going to be 4. Let's look at the next example again. And if I would like to explain the example first. So exponential function of base 3 and then log base 3 will cancel out, that it becomes x. So I want to think about next example, what's going to happen. It's going to be same idea, they cancel out, it's going to be pi. So from here, you can see the property of second one. It is going to be x by canceling out a and log base of a. Those are the inverse to each other. And I hope that everybody remember what is log base of 1 is, which is going to be always 0. Why? Because it comes from a to the 0th power is always 1. Therefore, inverse function will say that log base a and log base a, if you look at it, it is going to be cancelled out and it is going to be 0 as log base a of 1. So don't forget, it's a little bit tricky. Then what will be log 0? Log 0 will be undefined. If you think about the graph that we have learned, your log graph looks this way with passing 1 here. Your domain will be always greater than 0. So log 0 is undefined. The next property, log base 6 over 6, they are inverse to each other, so you cancel out and becomes 1. So therefore, if you look at next one, it is going to be 1 here. Okay, let's pay attention to the next 3 questions. So when you have a log with a product n times n, then you have to be careful. These 2 logs will be connected as addition, which actually came from, if you think about x to the 5th power times x to the 7th power will be x to the 12th power. We actually add the power when we multiply. So if it's a 2 logs multiplication, we can separate into 2 separate logs. So you can rewrite next expression of log base a of 21 is going to be 7 times 3. So I can rewrite as 2 separate bases of a and log 7 and log 3. Second property that you guys have to be careful about is the quotient of log with 1 term. In that case, 2 logs with a subtraction will be made in this property. So if you look at the example in this case, log base a over 3 minus log base a of 2. If you do one more time, next one, log base 3 of 1 minus log base 3 over 27, which I like you to simplify. That becomes log 1 is 0, so therefore my final answer will be log base 3 over 27, which I can actually rewrite? No, it's not. Okay, third tricky property will be when you have a power as r here, then the power of r can be rewritten as a factor r times log base a of m. So when you see the example, although the bases are not the same, I can rewrite as pulling 3 into front, 3 log base 5 of 8. However, in your calculator only have log base 10 and linear natural log as a base. So if you want to have log base 5 of 8, it's not going to be possible to write it into our calculator. So we have to change base formula, which log 8 over log 5, which has base of 10, or you can write it natural log 8 over natural log 5, which will give you the same answers. So if you look at here, change base formula is log base 10 over x over log base 10 over a, or you can write it natural log of x over natural log of a, which you will use for the calculator. And if you have a log base 2 over 14, as I mentioned, last two calculator do not show as a base 2, so we have to type it base with 10 log 14 over log 2, or you can type it natural log of 14 over natural log of 2. So brief summary of e function. If we have x is equal to x to the y, then we can rewrite it as natural log of a base e, which is same as natural log of x. So if you look at e as a base in exponential function, don't forget that becomes a natural log, which means log with base e. And I forgot the previous one. So if you want to change x is equal to 10 to the y, then I can rewritten as a log form, which is going to be log with base 10 of x. That case when we do not write base 10. So we can just omit base 10 and write it as log x. That will automatically indicate that you will have a base 10. I hope that this was a good summary. And then right below this paper, there is a in-class activities number 1. I want you to use the properties that we just reviewed, and please answer carefully. Okay, I hope you get to try your in-class activities number 1, and please compare the answer with my questions on the board. And these are the answer I got, and hopefully you got the correct answer. Good luck. So now it is main dish time, and let's just solve our exponential function and then log functions for x. So let's look at first one, how we can isolate by x in here. As you see, we only have a 1, so we just isolate the x and move everything to the other side. So first thing, I need to get rid of 2, 3, 4. Among here, I'm going to get rid of 2 first by subtracting. Then I'm going to have 3x plus 4 is equal to 5. Then, how am I going to get rid of that log 3? We are going to take a natural log or log 10. So natural log and natural log, that will actually help me to use a property of bring my exponent to the front side. So let's rewrite it. X plus 4 times natural log 3 is equal to natural log of 5. Don't forget that these are the numbers. These are the numbers. So I can divide by natural log of 3, natural log of 3. Then I'm going to have x plus 4 is equal to natural log 5 over natural log 3. So last step, I'm going to subtract and then punch into the calculator. So let's punch into the calculator carefully. So I got the answer without the calculator this, and after I punch in, I got the answer of negative 2.535. Let's try b together. So b is also, we only have one variable in here with a base 3. Okay, Okay, now let's try next question of b with base 2, and then we also have 1x in here. So same idea, we can isolate by x, which means we have to get rid of log base 2 and 25. So opposite operation of log base 2 will be exponent 2. So I'm going to write log base 2, 25 minus x is equal to 3. Then by taking exponent 2, you are going to cancel out these terms here. That will leave me as a 25 minus x is equal to 8. In this case, it would be easier putting x to the other side, move 8 to the left-hand side. That will make us 17 for my answer. Okay, I hope that I have enough space for C. So C, we have this time 2 separate x's. Last two question has 1x that we can isolate, but this time we have 2 x's that we have to combine them to in 1x. So let's see that how we can combine to one log. Subtraction had a rule that we can rewrite this one as division. So x plus 1 over x minus 1 is going to be equal to 2 here. Let me squeeze my by a little bit. So as you see, still we have 2 x's. However, we can get rid of the log base 5 by taking big 5. And these two are canceling out as inverse operations. So left-hand side, I get to have x plus 1, x minus 1 is equal to 25. So it turned it into rational equation. And if you remember, rational equation we are going to solve by cross multiplication. So if I cross multiply, I get x plus 1 is equal to 25, x minus 25. Then let's move x to the right-hand side, keep it positive. So I get 24x is equal to 26. So x is going to be 26 over 24. We can reduce as a 13 over 12. Okay, now we have in-class activities that will give you good review. I want to pause the video and then try these two in-class activities. And good luck. Okay, class, now let's check the answers for in-class activities number 2. I got the answer for x is equal to 2 or 1. And second one, I got 7 over 4 as x. Hopefully you got the same answer. Class. Okay, now it's gonna be the dessert part of the 1.4. Let's look at our apply the questions, and it's gonna be a little bit challenging, but it's gonna be fun for you while we're using this exponential and log functions. So example 3 says the population of California was 33 million in 2000 and 39 million in 2020. Actually, check the data. So this is a real one. Assuming that the population increases exponentially continuously, so we'll have the function of a e to the rt. So find the formula for the population of California as a function of time. So how are we gonna find this function? Luckily, they gave me two informations. Year 2020. Oh. One, two, three. So luckily they gave me two equations, which is going to be year 2000, I'm going to have a 33 million. Year 2020 is 39 million. And the format is going to be y is equal to a e to the rt. So let's plug in those formulas in here and then solve carefully. So it's going to be since year 2000, so we can rewrite this one as 0, 33 and 20, 39. Because our research started 2000, so that will make it a little bit easier. As you see that if you plug in, my a value will be 33, so I'm going to have y is equal to 33 e to the rt start with by plugging my number in here. Then I'm going to use the second point to find the r value. So y is a 39 million, and then it has to pass through 20 years. So we can isolate by r. So now let's isolate by r. So I'm going to divide by 33. And then after that, I'm going to take natural log both sides. That will give me natural log of 39 over 33 is going to be 20r. So by dividing whole this value by 20, I get as r value 0.00835, which actually shows as a 0.835% of increasing as a growth rate. So next question, I want to look at when the population is going to be double since 2000. I feel that the rate of increasing in California population is not as big as I expected. It's less than actually 1%. So I wonder when it's going to be doubled. So let's try to see our equation start with y is equal to 33 e to the 0.00835 t. Then I want to find that when it's going to be double, that means it's going to be 66 million. Normally in a population, it doesn't actually increase fast. I see, shh, 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 thanks. Sorry for the dog sound. So in this case, population doesn't increase fast, so I cannot actually guess how long it's going to take to be doubled. Normally being doubled doesn't take that long. About like 20 years will become a double. So in this case, I'm going to solve for t. Then let's divide by 33. That will give me definitely as a double e as to the 0.0835 t. Then let's take the natural log both sides. Natural log both sides. Then we'll cancel out. So I have a natural log 2, and then dividing by the factor of the front of the t will give me the answer. So natural log 2 divided by 0.00835. So after I punch into the calculator, it gives me 83.011, which means with this rate, the population will be 66 million about 83 years later. So it's gonna take about 83 years to be doubled. So about the time that when you die, probably the population is double. Just imagine that how crowded it is. With this rate, it will be taking about 83 years. Hope that you get to see it. So next one, there is in-class activities for you. I want you to pause the video and then try by yourself, and then let's compare the answer with me. 1, 2, 3. Okay, let's check the answer of the in-class activities number 3. So I had a 2.3,3006, 2.130,000 populations of the COVID-19 positive cases. And when I make an equation, my equation turned out to be this: y is equal to 3,000 e to the r as 2.188 to the t of t. And then when I want to find out when it's going to be 3 million as a COVID positive case, I replace y as a 3 million, and then I solve for t carefully. Then that gave me t as a 3.157. That indicates that about after 3 months later, the COVID case will be 3 million. And I hope that this question helps you to understand exponential function. And let's continue to. And good luck with finishing up this paper, and please upload after you complete it with me on the assignment 1.4 by Monday.